In this video, we'll be focusing on question 2 of the November 2015 metric question paper. So question 2 says the following geometric sequence is given. As you can see here on this page, it says geometric sequence. You need to know what a geometric sequence is. You need to understand so to calculate any term in the geometric sequence, you need to know the formula, and it is as follows. Tn is equals to ar to the power of n minus 1. So it says Tn, which is what the value of a term in the sequence, is equals to ar n minus 1. So this a represents the first term of the sequence. Then this r is a ratio. So to get this ratio, you need to divide a term in front of what, maybe like, to calculate the ratio, you can take, for example, T2 over T1 to get the ratio. So if we carry out the calculation, it would be 5 over 10. So the ratio is 1 over 2, which is a half. Or you can take term 3 over term 4, which is 2,5 over 5. It still gives you a half. So the idea is that you take a term in front over the term before it, then you get the ratio for the sequence. Yeah, as I've said, the ratio is 1 over 2, and remember the general formula is like this. So you substitute in the values. As I said, a is the first term. The first term is 10. Then r is the ratio. The ratio is a half. Then it's n minus 1. So n represents the term which you want to calculate. So as this question wants T5, then we'll put it like this. And when you punch this into the calculator, you'll find out that T5 is 5 over 8. That will be all for question 1. 2.2 asks that we determine the nth term Tn in terms of n. So what this question is asking you to do is actually to find the general formula for this sequence. As I've shown you on the previous question, Tn is equals to ar to the power of n minus 1. I've already calculated r, it's a half. So basically the nth term will be a is what, 10, since it's the first term of the sequence. Then r is a half to the power of n minus 1. So this is your nth term for this sequence. Question 2.3 asks that you explain why the infinite series, as you can see, converges. So for a series to converge, this condition must be met. So for a series to converge, the ratio should be less than 1 but greater than -1. So this series has r, which is a half. So as you can see, the r is less than 1 but greater than -1. Therefore, it converges. This is all that you need to do for this one. 2.4 asks that you determine sum to infinity minus sum of the n terms in the sequence in the form ab to the power of n, where Sn is the sum of the first n terms of the sequence. So what they're asking is, you can put it down and write it like this. They want to know what will be the value when you subtract sum of first n terms from sum to infinity. Okay, so to make it a little bit easier, you can calculate each of these separately. So you can start with sum to infinity, which is this one. Sum to infinity is calculated by this formula. As you know, a is 10, then 1 minus r. R is a half. This is equals to 20. Okay, then now you calculate the second part, which is summation of the terms in the sequence. It is given by this formula. There are actually two different formulas for calculating the sum of terms in a sequence, but I would suggest that you actually stick to this one because it works for all the cases of summation of the geometric sequence. Okay, so it will be, as you know, a is 10, and then 1 minus half to the power of n all over a half. This gives us 20 multiplied by 1 minus a half to the power of n. Then you expand the term. So our Sn is equals to 20 minus 20 multiplied by a half to the power of n. As we have calculated these on the previous page, you'll see that our sum to infinity is 20. Then Sn is as follows. So 20 minus 20 is 0. Then negative and a negative, it's positive. So you have a positive 20 multiplied by a half to the power of n is our answer. So this is our answer for this question. That will be all for the questions in question 2 of the November 2015 grade 12 paper. Please hit the subscribe button if you like the video and would like to see more videos from the Supernal tutorials, and give it a thumbs up if you found this video to be helpful, and check out more videos from Supernal tutorials. That will be all. Thank you.